Dear students, in this video tutorial, we will be learning about combustion reactions of hydrocarbons and alcohols and other organic molecules. First of all, you just to remember in combustion reactions, the reactants are oxygen and organic molecules, and products can be different. Just remember that in the products we will get water all the time. So we need some kind of heat and oxygen for the combustion reactions. We have two types of combustion reactions. One of them is called complete combustion and another is incomplete combustion. Let me show you the difference between complete and incomplete combustion. And just remember, as you can see in complete combustion, we are getting carbon dioxide, CO2, but for incomplete combustion, we are getting carbon monoxide, CO. Also remember that for complete combustion, we have enough high amount of oxygen per 1 mole of any organic molecules, but we have limited low amount of oxygen per 1 mole of alkane or organic molecule for incomplete combustion. Remember, for incomplete combustion, we are getting carbon monoxide. Please don't forget that in the questions. Also check for these keywords, either complete or incomplete, because the answers will be based on that. Also remember the color difference of complete and incomplete combustions. If you see this blue flame, it means that the reaction is complete, meaning that we have enough oxygen. But if you see orange, yellow, red flames, it means that this is an incomplete combustion. Also, it means that we have less heat. Also, we have carbon monoxide producing. So be careful about that. And how do we balance the combustion reactions? Just a key, whenever you see and like these formulas, always change it to this molecular formula. Uh, Let me write MF molecular formula so that it's easier for you in the balancing chemical occasions. So I have done some of this. So let's do this one, number 3. What's the first step? Instead of writing C5H11OH, we can write C5H12 and O easily. And so let's see how we should balance this one. Always remember that always start with the molecule that are only in two different molecules. For example, carbon is in here and carbon is in here. If I write 1 in here, we know that I have to write 5. If I write 2 in here, I have to know that I should write 10 in here. But oxygen is in within the 4 different molecules, so it's gonna be quite difficult to start balancing oxygen first. So let's start balancing carbon first. We have 5 carbon on the right and 1 carbon on the left. So let's write 5 in here. And I always write 1 so I know that this is already balanced. So then hydrogen, you see hydrogen on 1 molecule on the left side. Also, it's in within 1 molecule on the right side. So what we should do, and we should write 6 in here because 12 on the left and 12 on the right. So let's count the oxygen. We have 10 and 6, 16 oxygen in here, and we have 1 already in here. 15, we have to write 7.5. But do we keep it as 7.5? No, we have to make sure to change them to a whole number. So 2. It's gonna be 15 O2, it's gonna be 10 CO2, and it's gonna be 12 H2O. Always at the end after balancing, make sure to check one by one to see if all the elements in the balancing are same. And we can have different kinds of reaction based on uh, combustion reactions, so stoichiometric calculations, but this one is quite straightforward. We have done it during the lesson, but let's do it again. It says, deduce the balanced equation from complete for the complete combustion. We already did the complete combustion. Always write the chemical equation and take a look at this keyword, complete. If it is complete, we should get CO2, and you have to balance based on that. And it says a mole amount of carbon dioxide and mass in water. We do it one by one. So let's find out mole amount of carbon dioxide. First of all, after balancing, you have to know that these 1, 8, 5, they are the amounts, they are the mole numbers. You know that we from 1 mole of pentane, 8 moles of oxygen reacts and producing 5 moles of carbon dioxide. It says from 5 moles of from 2 moles of hydrocarbon. I have written 2 moles in here. The question is that how many moles of carbon dioxide? I am writing X mole on top of carbon dioxide. So on the top side, I have written the question. On bottom side, I have to write the from the balanced version. So this is 1 mole and this is 5 mole. We know that from 1 mole we are getting 5 mole. You have to make sure that you see moles and moles, they should be on the same side. So we know that from 1 mole we are getting 5 mole all the time. From 2 moles, it's easier. If we get 5 from 1, we should get 10 from 2 moles. This is the answer. We are getting 10 moles. But how do we find the masses of them? Again, so now it says how many grams of water. So we have given 2 moles of this molecule in the question. So I write 2 mole and they ask you how many grams. So I have to draw an arrow and put X grams of water. So from 2 moles, we have to find how many grams is this one. On bottom, we use the balanced version. We know that this is from 1 mole, we are getting 6 moles of water, but it doesn't ask for the mole, it asks for the gram. So we have to change the 6 mole to the mass. It's quite easier to change from mole to mass. You use the periodic table. Just remember on the periodic table, by the way, mass of 1 mole of water is 18 grams, so 6 mole will be 108. Just remember that in the periodic table, an element has two numbers, 5, let's say 12. Whenever they say that mass, always take the highest number, 12. So imagine we have A to B, and B is 2, 4, A is 512. So in order to find the mass of A to B, how do we find 1 mole? How do we find the mass of 1A to B? Let's take a look at A. Is it 5 or 12? It is 12 because this is the highest number. So, and we have 2A, so it's gonna be 24 plus B mass. Is it 2 or 4? Of course, it is 4. We should take the highest number. So A2B mass is 28 grams. So 1 mole of A2B is 28 grams. This is just for you to know how do we find the mass of 1 mole of any molecules. So this is about the combustion. Wish you all the best. Thank you.